Welcome everyone to another Observability Clinic, Advanced Metrics Expressions, Unleashing the Power of Dynatrace Metrics. Metrics expression are topics we've covered in the past. They are truly powerful. The true power is known by people like Alberto, who I've invited today. Alberto, thank you so much for being here.
Thank you for having me.
Alberto, metrics expression is powering most of the stuff we do in Dynatrace from a visual perspective, putting stuff on a dashboard, also querying data through the Dynatrace API to use it in external systems. And thank you so much for you and your team to really provide this powerful capability. But with power comes also kind of explaining how things work, what is really the power, and this is why I'm happy that you're here. Can you tell us what you have prepared for us, maybe how to get started?
Yes, of course. Let's jump right in. So what we're going to see today is, first of all, we're going to start with a quick recap of what is a metric, what is a metric selector. And this is from the previous performance clinic where my colleague Philip introduced the topic. And we're going to go through it not so much in detail, but as a quick review. And then we're going to see what new features and new possibilities we have introduced since the last time we talked about this metric expressions and different features that can empower them and increase the functionality and use cases. And then we're going to perform some queries together. We're going to see how these features interact with each other, what we can use them for.
That's awesome. And folks, if you're watching this, if you have any questions, also leverage the fact that you can either comment on wherever you watch the video here. You can also reach out to your Dynatrace team on the community. I think that's always a great place. And also share your metrics expressions with us. It's always great to learn from others.
Of course.
Yeah.
So what is a metric? So a metric is composed of a metric key, which is the unique identifier of a metric. And then we have 0 or more dimensions that compose a dimension tuple. We have here, for example, temperatures, the metric key, the dimension with the room and usage. And then, of course, we have a series of data points, which we can represent here as a list of values and timestamps. And this is all there is to it.
Yeah. One quick question. Is there a limit on dimensions? Like, do you know how many dimensions we can have?
There is a limit on dimensions. If I recall correctly, there's a limit of 50 dimensions per data point, and you can find on the documentation of the details, we have several limits, different limits on the number of dimensions, the length of dimension strings, and documented. You might find more links for these documentation resources at the end.
Perfect. And what I also want to highlight here, I really like the temperature example, but it really means that we treat every metric the same, whether it comes from the one agent, whether it comes through some of our integrations we have where we pull in data, or if people want to push data to Dynatrace, like the temperature example, I think is one where we can obviously see that we have an external data source and we're pushing it through the metric ingest API.
That is correct. From the point of view of the metric, it's all the same.
Perfect.
Now, what is a metric selector? We see here an example of a metric selector with an expression. So again, we find the metric key, and then metric key might be followed by 0 or more operators, such as here we have split by an average. And then we might find the metric dimensions that appear inside, perhaps as arguments to metric selector operators, such as here. And you might notice a difference since the last performance clinic, and that is that this metric expression does not have parentheses wrapping each operand. And the reason for that is, if you might recall from last presentation, we said that we introduced this requirement because we already had metric keys that contained characters that might also have been read as an operator, so a plus character, a dash, etc. And the reason we relaxed this requirement now is that monitoring the requests that we got, we could tell that the number of metrics that had such characteristics were actually very small. And so to make it easier to read and to write, we relaxed this requirement. The only thing is there are actually quite a few metrics that contain a dash sign, and that might be confused with the subtraction. And so the only requirement there is that you put white space around the character. So I will always put the white space because I find it easier to read and more pleasant to look at. And so this is a great improvement in my estimation.
Yeah, it's also, I know we use metrics expression a lot when we define SLOs, service level objectives. So we always have typically one metric divided by another to get to a rate metric. And this was always like where we had to put things in parentheses. And as you said, this is much nicer and cleaner to look at. Yeah.
Right.
Thank you.
So what are we going to go through today? So I selected here 3 operators that I find are worth to look more deeply into. And these are the most requested and most useful. And so the first one is the default operator, which allows us to fill data gaps in our metrics. And also this interacts nicely with metric expressions. We're going to see in a minute how. Then we have the fold operator, which has been enhanced with further functionalities. And it's really cool to look into this to see how this interacts also with other operators, although it's also useful on its own. And then we're going to look at the partition operator, which covers another couple of use cases which are very requested. So first of all, the default operator, we see here, we have some time slots and some data, and we see there's gaps in the data. If we use the default operator, we can fill these data gaps. In this example, I use the default 0, and that means that I take the argument to the default operator and use it as a value to be filled in the data gaps that are missing. And so we have here the example with the 0 replaced in the bottom here, where the data gaps used to be.
That's great, yeah. That's a nice visualization too, because people are visual. It's always good to have this. Yeah, awesome.
So, moreover, there's another functionality for default operator that works really well with metric expression. And let's take a look at that. So we can see here, if you remember from the last performance clinic, when we introduced metric expression, we said that the dimension values that are present in the result is only the dimension values that are present on both operands of the metric expression. So the simple case here where I have a metric A and metric B, we can see the dimension values that are present in the result are those shared by both of them. However, if I use the default operator, then I can select more than that. So in this example, we have the metric A and metric B, where the default is applied to metric B. And that means that wherever I have a dimension that's present on A but not on B, then the default value from the metric B will be used to calculate the expression. And so this means, in other words, that all dimension values from metric A will be present. And from these other examples, we can see with the other example from the default of metric A, so all metric values from B will be present. And if both have a default operator, then all dimension values will be present, both from metric A and metric B. So
it's also nice, which I think I told you in the preparation of this really great way of showing people what's really happening behind the scenes with the graphics. Thank you.
And let's take a deeper look with a concrete example. So we have an example here with metric A and metric B. They both have a host dimension, and the values are however different. So in metric A, we have host 1 and 2, and metric B has host 2 and 3. So let's take a look at the simple sum of these two metrics. We only have the host 2, because this is the only dimension value that is present on both metric A and B. And we have here the sum is 5, because as you can see here, 2 is the value for host 2 in metric A and 3 in metric B. Now, if we apply the default operator on metric B, then the dimension host 1, which is only present on metric A, will be 1. And then we sum it to the default value of metric B for each data point. And that means that the result is, again, 1. Now, same example for metric A with the default of 0. And so with metric B, which has the host dimension host 3, is present in the result. And here you can see on the last of the middle line, metric A with the default 0 plus metric B with default 0 has all dimension values. Now, we made the example with 0 as a default value. As you can see in the next example, default 1 plus default 10. Again, the host 1 dimension value that is present on metric A will be summed for each data point to the value of 10 from the default value of metric B. and vice versa for the host 3, which is present on metric B. Now, what happens if I divide? I have a division, and I put default 0 on both operands again. What happens is host 2 and 3, no problem there. However, what happens for host 1 is that I would have a result that is 1 divided by 0, and that's not a valid expression. And so the host 1 is missing from this expression. However, we can work around that because we can use again the default operator and apply it to the whole expression.
Okay, that's cool.
Yes, here we have the parentheses because we have to specify it applies to the whole expression. And what happens here is that I can specify a default value for the result. And so in this example, host 1, which is 1 divided by 0 again, in this case, the value 100 is used.
Okay, so that's great. So that means for every single metric, I can use the default, but I can also use it and apply it on the result of an expression. I think that I didn't know that.
That is correct. And this is very useful because, for example, if I want to calculate some kind of ratio, which is one of the most useful use cases, then it might be that the count and the success count, which are the two metrics that I'm using, some of them might not be sent. For example, if the counter is 0, they might not be sent.
It's funny enough, it came up yesterday in a discussion I had around SLOs. Same thing, where SLOs are typically rate metrics, where you're trying to find out, what's the coverage of, let's say, what's the success rate of requests coming in. And then typically most of our users are trying to split it by individual endpoints. And sometimes you don't have a certain endpoint, but you want to still have, and you want to report a value. And therefore the default on this is perfect. I didn't.
Yes, that is precisely for that use case. So moving on, let's take a look at the fold operator. Now the fold was already present, and the way it works is it takes all data points from a series and collects them into a single data point. And the way it worked without any argument was that it just takes the default aggregation for a metric and uses that to calculate the single value. However, what we introduced is the possibility to provide an argument, and I can provide, for example, max as an argument to the fold operator. That will be the aggregation that is used to calculate the result. So in this case, for example, we have here a maximum value of 10 for these time slots. And if I apply the fold max, I get 10 as the result, single data point result. So more in depth, let's take a look at this. We have one metric with a host dimension. We have, again, our host 1 and 2 dimension values. And I represent here the possible aggregations for this metric. So we have a minimum, maximum, and average aggregation that are available. And as I said, the fold without any argument, the average is used. So in this case, for host 1 and 2, we have the value 1 and 2. And if I use the max aggregation, instead of the average, the maximum will be used, and so on. However, something that's interesting to look at is that I can provide aggregations that are not available for the metric as an argument to the fold. And the way it works is that the default aggregation is used to extract the value from the dimension, and then the aggregation depends on the argument. So in this case, for example, fold count, we can see that first we will select the average aggregation, in this case 1 for host 1 for all data points, and then count means I will count the number of data points. So for both host 1 and 2, we have 8 data points. And then another example with the sum. Again, we select average, and then the sum of averages is 3 for host 1 and 6 for host 2.
Question here. If in your example, if I would only have one dimension, let's say only host 1, I would get to the same result if I just use the max, min, count, or sum aggregation function.
Yes, correct. First, you apply the min, max, or whatever, and then you apply the fold right after. Yes, if the aggregation is supported by the metric that is entirely equivalent.
I'm just trying, it makes a lot of sense to introduce the fold, because the fold is folding the different dimensions together, and then it's giving me the min, max, count, or sum as a result. Just
no, it's not folding the dimensions together. It's folding the data points together.
Folding the data points together. You're right. Yeah, that's what it is. Yeah, thank you so much.
Another thing to note is that these aggregations that are also available for other operators, such as the filter operator, the sort operator. Now, what are those operators doing when sorting or filtering by values? They are simply under the hood using the same value that the fold operators uses here. And since we can provide aggregations to the filter and sort that are not supported by the metric, then this is exactly equivalent to the value found here with the fold. Cool. So if I want to see by what value I'm filtering or sorting by, this is a great way to do it.
Cool.
Moving on.
Yeah.
Let's take a look at the partition operator. So I'm very happy with this because it really is very powerful, and how it works is simple. I have a metric here, and I can enrich it with an additional dimension based on the value of each data point. So the way it works is I select a dimension value, a dimension key first, and the dimension key that is not already present in the metric because we're adding a new one. And then we have a list here of conditions that apply to each data point in order to assign to the data point a new dimension value. Mm-hmm. So, for example, here we have dimension value D1 and D2. Mm-hmm. So let's take a look. At time slot 0, timestamp 0, we have a value of 2. And let's take a look. So value of D1 here, greater or equal than 7, does not apply to the data point of value 2. However, data dimension 2 with value of less or equal than 2 does apply, and so the data point of value 2 will have dimension value D2 in the result. Now let's take a look at the second time slot with data point of value 7. Then the second condition, dimension value 2 applies, and so the result, the first condition with dimension value 1 applies. And so in the result, 7 will appear with dimension value 1. Now, you notice that the third data point, 5, does not satisfy any of the conditions. And so that value is discarded. No value of 5 is present in the result. So this partition operator actually covers two use cases. If I want to enrich my data with an additional dimension, and then that dimension I can operate like any other dimension, so I can merge on it, sort on it, split by it, etc. Or I can use it to filter out data point that I'm not interested in.
I have thanks again for explaining this, because now it makes more sense. Coming back to SLOs, I talk a lot about SLOs. We introduced the default SLO where we give a metric expression like this, where we are basically using the partition to say how many requests are fulfilling the criteria of, let's say, being faster than 1 second. Because a very common use case in SLOs is, I want to know what's the ratio of requests that are faster than a certain amount of time. So now if you look at all the data points, we know what's the response time in every timestamp. And then we can say, now I only want to count those that actually fall within my criteria into this particular bucket.
Right, filtering and splitting.
Yeah, it's perfect. This is really so great. And so I see here GELE, I guess this is for greater than equals and lower than equals. Is there also other operators?
Yes, there are. There's a range. And you can also combine with and or not. Negate. Yeah. Yes, it's very powerful, and we have IntelliSense for that, and we're going to take a look at that really quickly. Awesome. So let's take a look at some query and that really put all of these features together. So I'll share. We have here our old friend, the Data Explorer. And so I'm really proud of my team's work in the metrics team, because we really added a lot of more functionalities to the metrics selector, and also auto-completion features for the Data Explorer. So, for example, if I query a disk metric, and as usual, we can filter, and we have suggestion for the operators. I can filter on the dimensions, and we have suggestion also for dimension values. So, for example, here disk, and a new feature is we also have, as you know, in the metrics selector, we have embedded entity selectors, which are powerful nested language. And we also have support for suggestions for that. So, for example, a thing that's very powerful but hard to use is relationship queries. And in this case, for example, I want to see, I want to filter on the host of this, so I can just write is this a host? And then here I can write an entity ID for the host, and we have suggestions also for the value of the ID.
That's awesome. So just that I understand this, what you're doing here is give me the available disk for those disks where the disk is in a relationship with the host, and the host is this particular host ID.
Yes, exactly. That's precisely what it does. And also we have introduced many more features. A great feature is, for example, we introduced in the last performance clinic an example of converting from units to another unit. The example was Celsius to Fahrenheit, for example. And now Dynatrace supports a list of units, and you can convert between those by using the 2-unit operator. For example, here we can convert from bytes to bit, and use this as a shorter and a better way to convert units. And I encourage you to find the link to the documentation, to the metric selector, and the metric expressions. And this really goes more into detail, and every feature is documented there, every operator. It's really useful.
Quick question on the 2-unit. Do I need to know the source unit, or can I keep it empty and then it takes the default unit?
The good thing about the auto-completion is that it will suggest automatically.
Automatically the right unit,
Yes.
Yeah, that's good.
But of course, if there is some intermediate expression being evaluated there, the user can also set the unit with the set unit operator, or just convert from different units. So this set unit operator, for example, allows me to force the result to have a specific unit without converting.
Wow.
Now, you mentioned that in SLOs you try to compute the value for the percentage of data points with a certain threshold. So let's look exactly at that example. For example, let's take host CPU usage metric, and let's filter by a specific host.
Yes, something just happened here.
For some reason.
And we're back in business. As we know, this is why it's live. It's almost live. We don't cut it out. I guess your Zoom just crashed.
Or something
happened.
So let's filter by a specific host. We have let's take a look at our data. Now, let's say I want to find all data points where the value, the average CPU usage is below 20. The way we can do it is use the partition operator. Now I have to extract the average value first.
I think it needs to, perfect. Now we see the data, perfect.
Because the partition operator expects already aggregated data. So let's use the partition operator. I create a usage dimension, and I define the usage as low if it's lower than 20. Let's see. And as you can see now, all the data points above or equal to 20 have been filtered out. Now I want to see the percentage of data points that are below this threshold. A way I can do this is by dividing the metric by itself. So let's do that. And divide. Now I get an error. Why is that? Because you remember from last performance clinic that the two operands need to have the same dimensions. But they just created a new one with the partition operator. But since it's a dimension like any other, I can just merge it away again. And here we have our result. Here we have every data point, of course, is value 1 because we're dividing by itself. And now we can count them. And to count them, we just switch to fold to single value. Here we have 39 data points. And now let's multiply by 100 to find the percentage, right? Oh, 3,900% does not sound right. Now, what is the reason for that? Because First, the metric is calculated for each data point, and then we're finding with the default aggregation, and the result of calculation is always a count. It's always a quantity. The default aggregation for that is sum. And I can work around that by telling the data explorer to use default average. And now we have 100, still doesn't sound right. Well, what happens if I use the default operator here?
So it means for all the data points that are not larger than 20, you get a 0, and therefore you're then dividing.
Yes, exactly. Otherwise, I'm just calculating the average, but I only have the 100 value data points.
That's awesome.
And now I have the correct value. Another way we could compute that is if we use the default count, because we counted the number of data points beforehand. Here we have it. We use it on both members, and here we have it. Now, this warning just tells us that count is not supported by this metric in particular, but we said we can still use it for our calculations.
The partition use case that you bring here with the usage of low, that means you could also do a low, a mid, and a high.
Yes, right? Of course. Let's try to do that. So we have here the partition operator. We already have a low, and we can create another partition. Let's use the partition high, which is, let's say, greater than 21. And let's see. Let's take a look at the result. We're still in single value mode. Now we have two dimensions, as you can see, the low value and the high value. And still we have a host dimension, of course. We have a single host, but we can merge the host dimension here. And now we have only the usage dimension with low or high values.
Yeah, that's awesome. That's
now
cool.
There's maybe I want all data points, but some data points are nor low nor high. How can I do that? Well, we have a catch-all condition here otherwise, and we can write mid, and the partitions conditions are evaluated left to right, top to bottom, and that means that whatever does not match any of the previous ones will be matched by the last one. So in this case, when it is exactly 20, here we have it, 3 different values.
That is awesome. And if you do a heat map on this now, just wondering if my brain works correctly, heat map. Can you see? It's awesome. We're squeezing it together between. No, it's awesome. It's really cool.
I'm glad you like it. I also love it.
Yeah. Folks, this is the magic of matrix expressions. Yeah,
exactly. So let's go back to the slides. And yes, as you can see, I prepared some images here that shows what I just presented. And at the end of the slides, which will be made available for the users, then we have some useful links to the metric selector documentations, the best practices with metric expressions that cover most of what we introduced today, and some FAQ.
Perfect. Hey, I have one more question. Can you go back to your browser again?
Yes.
Because I would really like to highlight one thing. If you are, do me a favor, just go back to just use the metric, the host CPU usage, like remove everything else.
Yes.
And then just show also the filter, remove the filter.
Okay.
Can you just open up the, what's it called? The suggestion, like what, if you do a double point now, So folks, there's a lot of cool stuff. I really like the code completion. That's why I missed the word. The code completion really shows you everything. And there's so many things in here that you can do. You can merge. I wasn't aware about the set unit. You can obviously sort the stuff, split it by time. What is time shift?
Time shift allows us to take the value of the data points, but we change the time stamps. So by a certain unit, for example, -1 minute, it will show me the data points. So 1 minute, same data points, but with a timestamp of 1 minute in the past.
That is cool because that means you could use this for, oh, be a good application for that if you're shifting times for prediction purposes, maybe. Yeah, but awesome. Then I know we talked about this because a lot of people come to us and say, hey, it's really powerful, but I have questions. I learned about the rate metric, right? There's things like this. You told us about the partition. That's great. Are there any other, I don't know, functions that you see being used a lot besides those that you mentioned, or was this pretty much?
Well, filtering and sorting and limiting are always very much used, but those have been there for the longest time. So I selected maybe newer stuff that is equally as useful, but not as used yet because people haven't heard of it.
And then the last thing, maybe, I know you can switch between code and build tab, especially if it's obviously,
yes.
What I always find useful, if you're completely getting started with it, you start with the build tab and then you switch over to the code tab.
Yes, precisely. So let's get the disk available metric from before. And I can aggregate by average and split by, which means what dimensions I want to keep, in this case, none. And no filtering is defined in this case. If I switch to code, here I have the corresponding metric selector.
And also, if you go back to the build tab quickly and go into the filter by, that's what I always found very useful, and say you want to filter by disk. And I think you also have the host is disk off, right? Yes. I mean, the relational stuff is already, it's also really nice there in case you are, still more familiar with the visual approach. And then this will also create the corresponding metric expression that you see in the code tab. Yeah.
Precisely.
Yeah, really powerful. Alberto, this was awesome. Yeah, we even survived the Zoom crash.
Oh, yes.
But this just shows that we're doing this because we love it, and it's great that we share educational content, especially when it comes from the source, from the people that implement it.
Absolutely.
Thank you. And I want to have you back because I'm sure there's more coming.
I'm glad to be back.
Yeah. Thank you. Bye-bye, everyone. See ya.
Bye-bye.